types of trees. This lecture is to discuss about different types of trees that are present, so that in the coming lectures when we discuss about the properties or the applications of different types of trees, you should be clear about what are these types of trees and what data structures we are using. So this is a general introduction lecture for different types of trees. So the first thing we'll discuss is a general tree or a generic tree. That is, there are no particular rules. Any node can have any number of children. So let us say you have this node. This can have, let us say, 3 children, and each of those children may have any number of children. Let us say this is having 2 children. This is having only 1 child. This is maybe having another 3 children. So this is called a generic tree or an n-ary tree. Okay. General tree, generic tree, or n-ary tree, whatever you may call. This is the general structure, whatever be the number of children on any trees, which also means in the coming other types of trees that we discuss, there will be restrictions on the number of children. Okay. So the next one we'll discuss about is binary tree. So coming to our tree lectures, most of our discussions will be channeled on binary trees because they have a lot of special properties which will allow us to do many specific operations. So binary trees, any node can have at max 2 children. So either it can have no child, or it can have 1 child, or it can have 2 children. For all the nodes, it can have 2, it can have 1, or these are not having any children. Okay, so it can either be 0, 1, or 2 children, but it cannot have 3 children. Any node cannot have more than 2 children. So the children, you call it left child and right child. Okay, for addressing. So for example, for this node, this is the left child, this is the right child. This is about binary tree. Next is ternary tree. So ternary tree, similar to binary tree, it had maximum 2 children. Ternary tree will have maximum 3 children. So let us say this is having 3 children, this is having another 3 children. This is a ternary tree. So it can maximum have 3 children. That is what you call as ternary tree. The next thing is binary search tree. This is a variation of binary tree. So binary tree property holds, that is maximum 2 children, that holds, plus there is an extra condition that each node's left child can only contain values that are smaller than the node. So let us say this node is having value 10. Then in a binary search tree, left child can have only those values which are smaller than 10. For example, this can have 5 because it is smaller than 10. What about the right child? Right child can only have values which are larger than this. So larger than 10. So let us say this is 12. This is allowed. But this right child cannot have value, let us say 6 or 7. That's not allowed because it is lesser than 10. And what about further children? All the further children should also satisfy this property. That is, if you are having a right child of 5, it should be lesser than 10 because it's on the left side of 10. And it should be larger than 5 because it's in the right side of 5. So this can have value something like 9. So this is a binary search tree. In binary search tree, binary tree properties plus this additional property of binary search tree, which says all left child should always have value smaller than the parent and right child should always have a value larger than the parent. So this is a binary search tree. Next thing is a balanced tree. So what happens is, if I draw something like this, one child is here, this side I am having so many children like this. This is a skewed tree because lot of children are there on this side, but on this side there is only one child. So this is a skewed tree. A balanced tree will always have some particular rule that it should always have minimal height difference between left and right subtrees. For example, this is a balanced tree. This is a balanced tree because if you see the left subtree and right subtree, the height difference is 0. So this is a balanced tree. So it need not always be 0. Depending on the particular balanced tree you are using, there will be certain rules that this should be the height difference or that should be the height difference. So that will be clear when we reach those lectures. We'll clarify on what are the exact rules for those. Next thing is a full binary tree. What is a full binary tree? A full binary tree, any node can have either 0 or 2 children. It is not allowed to have one child. Okay, this is a full binary tree. For example, this has 2 children, this is allowed. This again can have 2 children, it is allowed. This can have no children, that is allowed. But it cannot have one child. This is not allowed. Okay, it can have 0 or 2 children. So any node can have either 2 or 0 children, then it is called a full binary tree. The next thing is a complete binary tree. What is a complete binary tree? In a complete binary tree, all levels are fully filled except possibly the last, which is filled from left to right. That is, for example, this level is fully filled. This level is also, let us say, fully filled. This is not fully filled. I am only filling till this. But it is filled from left to right. So, for example, this one is not a complete binary tree because all the levels are fully filled till this, and in the last level it is not filled left to right because here a node is missing. Then it is not a complete binary tree. For it to be a complete binary tree, last level should be filled from left to right. So if there is one more node, that should be the left child of this. If one more node is there, then should be this. Okay, so all the previous levels should be completely filled, and the last level may or may not be completely filled. If it is not completely filled, it should be filled from left to right. That is the rule for complete binary tree. We'll discuss one more type of tree before we wind up this lecture. That is a perfect binary tree. What is a perfect binary tree? All the levels will be completely filled. That is, all leaf nodes are at the same depth and all non-leaf nodes have 2 children each. So this is a perfect binary tree. This is a perfect binary tree. What are the 2 rules? One is that all the leaves should be at the same levels and all the non-leaf nodes should have 2 children each. This is a non-leaf node. It has 2 children. This is a non-leaf node. It has 2 children. Again, this is a non-leaf node and has 2 children. So this is the rule for perfect binary tree. So we learned about general tree or a generic tree or an n-ary tree. Then we learned about binary tree, ternary tree. After that we went to binary search trees. After binary search trees, we learned about balanced trees. Then we learned about full binary tree. Then we learned about complete binary tree and perfect binary tree.